I thought we were going to be light on attendees today, and all of a sudden we got a full room. It's great. So again, for the people that weren't in the room, let me introduce myself again. Tim May. I host the AI Meetup, and today I'm taking an article written by Matthew Renzi, a well-respected data scientist and speaker. He wrote an article, have we reached peak AI yet? And it was a great article, and I asked him to come speak, and he was unable to attend. So I asked him, could I present it for you? And he said yes. So that's what we're going to do today. We're going to review the points he makes in his article, and I would encourage anybody that finds any of that really interesting to go read the article, and what's more, and why his article is special. He's got lots of links in the article to the source materials he used to develop his presentation. So you can dive deep, and that's kind of fun. There's papers and things like that. So I'll point some of those out as we go along. So let's get started. By the way, we have a microphone. If anybody has a question, just kind of wave your hand and we'll get the microphone to you. I encourage people asking questions along the way. Can we slide the door closed, please? Thank you. All right. So these are it's a research summary that we're presenting here on his insights, and you can see he's got MatthewRenzi.com. It's a great site. He's got courses and lots of interesting articles. So have we reached the top, and are we headed downhill? You hear a lot of different opinions about where we are in terms of the technology and how it's going to be applied, and whether there's more to be done, what will that look like? Or we kind of reached the peak and it's just going to be disappointment and disillusionment from here forward. And one of the things that we often use to measure where we are in a technology adoption curve is Gartner's, curve here, where they go from the innovation where people say, oh wow, we can, to the people get really inflated expectations about what they're going to be able to do with the technology. And then they kind of fall off of that. There's this trough of depression where the expectations drop really low. And then finally, over time, there's this slope of, people start to really understand technology, the slope of enlightenment. And who makes this stuff up? And then finally, the plateau of productivity where, hey, the technology is well understood. There are lots of implementations that people can look at to say, hey, will that work for me? So where are we with AI? Well, Gartner in 2023 put generative AI up at the top. You'll see that that's a blue dot, and what that means is they're saying, hey, it's about 2 to 5 years out to we're at the plateau of productivity. So any of those dots that are blue, that Gartner's saying that they'll be here in 2 to 5 years. And then there's one reinforcement learning they have way down. It's early and it's dark blue, and that says, okay, that's 5 to 10 years out. So I'm not going to make any comment about whether they're right or wrong, but it's an interesting way of looking at the question. And it gives you some idea of what one of the largest technical analysis firms in the world thinks about these technologies. Okay, so on this particular slide, we see a few other AI-related items that I haven't dived into. There's actually a lot of different things that Gartner, for instance, is looking at in terms of trends, particular technologies and their applications of those technologies, all based on foundational models, LLMs being one of those, right? So this is what Arn said about it. The popularity of many new AI techniques will have a profound impact on business society. Most people go, yeah, of course. Well, he said that before a lot of people were saying it. And then finally, the massive pre-training and scale of AI foundation models, right? Viral adoption of conversational agents. I've done talks here about some of the work, for instance, Microsoft is doing in their conversational agents. It's amazing stuff. And the proliferation of generative AI applications, which almost everybody in this room, I'm sure, has used. Who hasn't used ChatGPT or an equivalent? Not a single hand goes up, right? Okay. And, are leading a new wave of workforce productivity and machine creativity. And again, this is from the guy that runs AI, runs all the analysts at Gartner in the technology area. So that's a pretty big statement. So bottlenecks. Well, what are the things in our way from getting from where we are to where we ultimately want to be? Elon Musk said GPUs are harder to find than drugs. But his XAI data center, they built a 100,000 GPU supercluster in 19 days. 19 days. It used to take years. They did it in 19 days. So, okay, don't know what kind of drugs he's getting into, but it's a lot of GPUs. And he, by the way, a side note, he has said, we're going to kick everybody's butt. He's made that. He said, we are going to be the leader. We are going to have the most sophisticated models there are. And we'll see what he's done some wild things, so maybe he will. Human-generated data is limited, but what about synthetic data? So here's the idea. They say, oh, we're running out of things for these machine learning LLMs and whatnot to train on. They've eaten all this text. They've sucked it all up. Yeah, but the problem is that the solution is we can create synthetic data, and it can be curated. It can be tailored to a purpose and delivered into the machine learning pipelines. So we are not actually too limited on data. And Mark Zuckerberg recently came out and said, but power is a problem. It's going to constrain our growth. And then Microsoft bought 3 Mile Island, and they're powering it up so they can run a massive cluster. So there are solutions. Absolutely.
Okay. So data is limited. Data is limited, but if we've consumed all of the human-generated data in the world, why do we need more data than that?
When you look at the way neural networks, at least in the LLM space, work, they are a statistical model, right? And so sample, it's all about garbage in, garbage out. A lot of human-created data is garbage. And so one of the things you have an opportunity to do with synthetic data is use heuristics and other AI machine-generated algorithms to pull the nuggets, the good stuff, out of all that garbage. And so you can create synthetic data sets that they might be smaller, but they are higher quality. And then you can use heuristics to take that data and generate other similar data at scale to increase your sample size. You introduce model bias, you have a lot of problems that you have to avoid in doing that, but that's the idea behind it. Okay, yes. Oh, can we pass her the...
I just wanted to add to that answer. So I used to work for Chooch, which is a visual AI company. So the reason why you need synthetic data, okay, as well as human data, is like, for example, accuracy. So let's just say if you're trying to figure out, is that really an airplane? So the computer's trying to decide that. If you only have like one picture of the front, you can't really know for sure, is it that particular car or plane or whatever. But if you generate all the different angles, okay, then you can increase the probability that that really is that object, up to like 99.9%.
Absolutely.
Without synthetic data and that generation capability, you have no way of actually knowing what you're looking at.
Great. Okay, so scaling large language models. Like, you've heard a lot about these large clusters that are being built. And the question is, why do they need such a lot? Well, because we have to scale to get performance. And there's something called the, well, I'll get to that next slide. But one of the things that we could look at is this is done in 2022. This was how far along models had come in hitting the human level performance. You can see, even back in 2012, we were going past the human level capabilities. Remember the early speech recognition systems, how really bad they were? Well, by the time we get to 2016, actually before that, they were better than most humans. So we saw better than human level capabilities. And you can see there were lots of other bits and pieces where we're getting the code generation, school math, what have you. This was 2022. And so there was a study that was done, and they basically went in and they looked at, this is OpenAI and Johns Hopkins together, went in and they looked at, well, what are the relationships between how much resources that we throw at the training problem and the results we get? And they discovered what they call a power law. It basically shows us that there's a linear relationship. Actually, it's on a log scale, I suppose. But the idea is that there's a very predictable increase in capability based on the amount of what you put in, the size of the compute data and the amount of compute you actually do. And so you can see it's on compute data set size and the number of parameters you're using for training. Increasing all of these can result in better results. It does plateau eventually, of course, but they said you could go on for ad infinitum. You can do it forever. You could just keep getting bigger, but of course, that doesn't mean it's practical. So there's a really good link in Matthew's article to a YouTube video where somebody goes through all of these steps. It's about a 30-minute video. It's one of the best you could watch. So I strongly suggest you take a look at that. It's a great video. So scaling large reasoning models. Reasoning models are relatively new. Last month we talked a little bit about chain of thought. We were going to kind of dive into that in this talk. So chain of thought is basically breaking the problem down in lots of little bits, and then along the way checking your results and making sure you're trying lots of different things and you're only selecting the best course of action. And after a while, you can get big problems decomposed into a lot of smaller problems, each of which can be measured and found to be good or a bad solution by in and of themselves. So you can kind of incrementally creep up on it. And what they found is that by doing this, the Open AI 01 model went much higher in rankings. It just blew past what it had done with 4.0. In fact, you can see the differences here. The AIME is a really cool test. It really looks at math skills at the higher levels, and it started to blow the doors off those kinds of exams. In fact, in the next slide, we're going to look at. Pardon?
I have a question about that.
Sure. You pass that down.
So I'm almost always blown away with the improvements when they change models. This is mostly a question, certainly for you, but also for the audience, a little sample size. For anyone that's used this, have you gotten any worse responses from the strawberry model?
Yes.
Because I surely did. It felt in some ways like I was taking a step back. I was like,
well,
it's got to be so great it can think.
To be honest, you're not using the GA, right? It's only a preview. The strawberry model that's out right now is preview, and it's for instance, I had a question, a technical question, purely technical. I dropped it in, and it said, "I'm sorry, that violates our guidelines." You know, what? It's a purely technical question. It had nothing to do with anything, and it was like, "Well, that's weird." Dropped it into the original 4.0. Fine, I got a great. Dropped into Claude, got a great response. So it's let me down a couple of times.
And as just one wrap-up note on that thought, it would let me in the 4.0, it would let me reference all of my prior discussions and do that. And then when I went over this, I'm like, now based off of all of this, it's like I have no idea what you're talking about.
No, they haven't hooked all that stuff up because that's prompt engineering in the back end, not so much the model itself. All right, so.
So I was going to say something real quick.
Sure.
I got this. Hold up. I was going to say.
The mic is for the recording. Yeah, it helps us that way that people that watch this later can.
So when O1 came out, I was reading the release from OpenAI, and they said that for natural language, like content generation, that humans preferred the previous model.
The technical term is alignment. It had better, higher alignment.
Yeah.
And they're working on that in the preview to get. The reason it's preview is there are many unfinished sort of final touches, if you will, and even some fairly interesting underlying architecture they're not done with yet.
Yeah. I don't know how it is now, but they said that humans preferred the 4.0 for content generation as opposed to.
Yeah. I think part of that was what Josh said, is that it would had better ability to use an expanded context window, i.e. previous conversations. So that's a prompt engineering problem, not a model problem. You understand, when you take a model and you have to feed it the current context along with your latest prompt. And that process of managing that context is a prompt engineering problem. And they've done a really good job of that in the 4.0. From what I've seen on the 01, not so much yet. But that's just a matter of time. Mm-hmm. So there's a big difference between underlying model capabilities and how you use them in a product like ChatGPT. Okay, so there's some numbers here. If you want to see the differences, competition math, what we just talked about, you can see the GPT 4.0, you can look at 01. Look at the difference. 13.3, and then the preview was 56. What you haven't got yet is the actual 01, 83.3%. That's a pretty significant, that means that these models are performing at the level of the top 500 students in the country. Yes?
Well, one thing to keep in mind about this is that you don't necessarily know the data that this model was trained on, right? So just because it's a benchmark, if it's trained on the data in these competitions already, it's not so much.
Wait, we're talking math. Math is a thing. It's a discrete body of knowledge. It's not it's not a soft science. Very hard. It's very deterministic. So of course you train on math, but everybody's using the same math.
But the idea is that you're still inputting data into this model to train it, And if this data set is contaminated with that benchmark,
that's
not
forward
really
bias in a model.
Was that?
It's forward bias in a model. I think what you're trying to get at. You're saying, look, if you trained on something, you can actually overfit. You're really good at that, but not much else. So what we're really worried about is how generalized is the model. How is it at handling stuff it hasn't seen before?
But you don't know that it hasn't seen it before, do you?
Well, the data scientists who are running these trainings do.
We don't know what the GPT was trained on.
Well, I guess the point is that they don't necessarily train on the content of the test. They train on the mathematics, and the test is a test.
No, we don't know that it wasn't trained on the content of the
They
test.
claim that
They claim, but it's trained on the pile, which is like 500 terabytes of. We don't know.
I guess we say, how much do we trust what we're hearing from the folks that are creating these models and the training? I don't know. There are independent studies.
Yeah.
There are independent studies outside of these provided by OpenAI, and from what I've heard, they're getting similar results. But
it's just a question you have to ask, like when you're doing data.
I agree.
Like, what's in there? Go ahead,
Thomas.
For what it's worth, mathematics is not really that complicated from like a training process. The big problem was chain of thought, allowing them to move through the multiple steps of the problem. But the domain, there's probably only 500 classes of problems, right? That's not a very large set of problems for a LLM to train on. So you're kind of right. It is overfitted to the problem class of these tests, but that's literally what studying means. But the issue that we were having was that the LLMs were not able to move through the multiple steps of these problems because they required very difficult composite thinking, and it would hallucinate what it perceived to be answers because they're basically character predictors, right? So it was their own ability to interrogate their own process that showed the major lift here.
And by the way, the big change, the most significant advancement from 4.0 to 0.1 was the introduction of chain of thought reasoning. And you can see that in code completion, kind of the same problem, right? We're having to take really complex problems and break them down in little smaller steps and check our steps along the way. And then finally, the PhD level, this one blew my mind, science questions at the PhD level being answered. That's pretty cool. Basically, they were getting like 97%. That's right up there, some of the very best. Yes, you had a question.
So I don't know how much this information relates, but on Friday I came across an article that my team shared on GSM symbolics, and it's math related. And basically it was saying that these models don't do very well in reasoning when it comes to math problems.
They do now.
They do now. So the article was about GSM symbolics, and they came up with templates for the training.
Sure.
Well,
my research was in the area of symbolic regression, so we were all over that. And the big problem with these models is they only do continuous functions. They don't handle discontinuous functions. In symbolic regression, you can do that. But symbolic regression is like 1,000 times more expensive to develop a model. So, there's trade-offs everywhere, right? So one of these days, these will all merge. But there's a whole family of algorithms in the symbolic regression arena that you might want to look at if you're interested in that area.
So how does this GSM symbolics
I'd have to read
relate
that
to?
article. I haven't seen
okay.
it, so. But in general. This is another, I think, very interesting demonstration of the difference between 4.0 and 0.1. You can see how much the orange is the improvement. Right across the board, except for maybe the AP English Lit, which is already pretty good. But the softer the science, sorry for English majors in the room, the less it did. But you can see, this is a real improvement. And by the way, now there are models coming out that claim to be even better than 0.1, right? So we're seeing the new Llama stuff and the new Gemini stuff, just a lot of advancement. Now I'm going to get down and dirty and chain of thought. Everybody's seen a tree graph at one point if they've done any engineering at all. This one is relatively simple to understand. We start at the top and we try a solution and it doesn't work, so we bifurcate. We try two alternative solutions. And then we bifurcate, we try solutions, and we keep going down this tree, and you can follow this from here to here to here to here to here to here to to here, boom, right? So, but it did all these other tries. And every one of those was abandoned because it didn't pass muster. In some way, it didn't measure up in terms of the error measure being applied. Yes, TJ?
I had a really strange thought. In a way, is this almost like genetic prompt engineering?
What is genetic prompt engineering?
No, I'm saying like in the same way that you'd have like old school genetic learning algorithms.
Okay.
This is creating a tree and then testing the elements of the tree to say like which is the most rational.
Well, tree search is a well-known, understood machine learning technique, but what's new is the way it's being implemented in deep learning models, deep neural nets, to avail yourself of the opportunity to apply an error function in an incremental fashion, rather than end of what they call outcome reward models look only at the end and say, okay, we do a model and we measure the result here. What they're doing is they're doing incremental measurement of the outcome along the way, and it allows them to not go down too many non-productive paths, or to compare two alternative paths to some depth of test based on your compute budget, right? You can say you can go as many different trees as deep as you want with infinite budget, but of course we have to have some cutoff. So it does a sensitivity analysis both on the result that's being provided and how much compute it took to get there. And so it's doing a greedy search in that sense. It's looking at the cost and saying I won't go there unless I can afford to. We got another.
So I'm not sure if you're going to touch on this in a later slide, but so there's two key things I see going on when I look at this tree. So going down and out, you said you have a bifurcation. So I'm just curious what the criteria is for like generating two alternatives based off your previous one. That's
a great question, and there in that video, the YouTube I mentioned that you should watch has a great answer. But in short, what the answer is that there's not, we work with probabilities, and a lot of times there's not just one good answer. There may be 2 or 3 or 4 good answers, just different levels of probability. And what we do is we apply a logarithmic scale or exponential scale to the errors, so the further away from the perfect answer, the harsher we are. So you might want to take those 2 or 3 closest solutions that are probabilistically probably the right answer. As TJ said, it's, they're just generating new tokens, right? So there might be 2 different tokens that are equally valid as part of a response, but it depends on what comes after that as to whether they're the fully correct response. Well, that means you have to keep generating tokens. You're going down one of these trees. And so what we do is we say, okay, what's our budget for that probability around the correct answer? Right? And that's what allows us to decide how many different things we're going to try. So if this was a very simple idea of the tokens, say, well, I got 2 possible tokens that follow this token, and we'll see where it goes. Oh, I didn't like any of these, but I like that, and keep going down that route.
My AI knowledge is really outdated, but how is this different from random forest and Gini impurity?
What makes you think it is? We just recycle old ideas and use them in new ways. Actually, random forest has a slightly different methodology around penalizing error, and although it works on probabilities as well with Bayesian and whatnot, it's I've written some of the code down deep in Bayesian classifiers, for instance, and using random trees, and they're a little bit different in the way they generate the options. With the LLM, what you're getting, and specifically LLM, is here's 5 tokens at different levels of probability, and you pick the top 3 and spend compute on that. It's a little different than the way we decide what to do in a random tree walk with Bayesian classification. But it's essentially just messing with probabilities to decide what we do next. I probably should have meant that these yellow are, hey, this is a good step. Both of those are equally good steps. We'll try them. Equally within the range of the probability error. Incorrect, we tried it. Oh, that was bad. We don't want to do that. And of course, each of these little blue circles is a partial solution, ultimately getting down to what you get as your final result. I know it's an ugly graph. Another question?
Yeah, I just want to so the other aspect I'm curious is how does it rate what's a good path and what's not?
Probability.
Sure, but it's trying to answer a question, right?
Yeah, it's probability. It's probability all the way down, turtles all the way down. Every single token, when you talk about a transform generator, what it's doing is it's just saying what token comes next. and it's using probability to decide which of those tokens to give you. What this is representing is, hey, there's a lot of different maybe options of the next token. I'm going to go ahead and use that one and see how it looks. And it's, you get further down, you realize, oh, that wasn't a good way to go. You back up and come down the other way again, right? So it's just the breadth, the number of tries based on how close the next step looks to be in terms of probability. Does that answer your question? No, it's kind of deep.
So is the probability for the next token not necessarily for everything so far up to that point, or are those the same thing?
Well, we are talking chain of thought. So you've raised another aspect not demonstrated in this diagram is the tests that are applied to decide whether or not that's a valid path. So yeah, when we check our reasoning, there's a whole nother set of heuristics that could be applied to decide whether it's a good next step or a bad next step outside of probability. When you talk about checking something, you're actually applying a heuristic generally, right? I don't even know how they do all that and all the different ways they currently do it, but it's a general idea. Did you have a question? Oh, Josh again. Yeah.
I have a quick question. So I think to sort of paraphrase what I think I heard over there, with the preview of 01, I would notice I had to be very clear with what the criteria for success was. So for example, if I said, I'm tired of feeding my cat, what can I do? I could say,
shoot the cat.
Shoot the cat. Right. Now you don't have to feed it anymore. So then you say, okay, so I love the cat. I would like the cat to eat. I'm tired of feeding the cat. How can I solve this? One of the biggest things that I've found with these language models is somewhat unsurprising in retrospect is your communication skills with other humans actually make you much better at talking to the robots. And so if you gotta assume it doesn't know anything about you and what you value. It only knows what you're going off of. So you say, I love my cat, I like it to eat, it should only eat this many calories, what should I do? When it's going for the probability on like a chain of thought like this, it would probably put automatic feeder closer to the top than shooting the cat.
So it's the evil genie problem, right? When you remember the 3 wishes, and,
Yeah.
and it's, you always end up on the short end of the stick because he manages to make the wish not work out for you. So we don't have an evil genie, but we do have the problem they not understand what you really want. So you get lots of options you would have never thought of, right? So, yes. All right, so power laws again. Scaling large reasoning models demonstrate the same relationship among scaling resources and performance that we saw with scaling the LLMs, the foundational models. So that means that by adding, chain of thought, we get even more headroom and we have the same kind of power law relationship involved. So that just means that we throw more resources that we can get continued enhancement over time. That's big news. A lot of people didn't know or actually felt very strongly we would not be here a couple years ago. They were of the opinion this could never happen, and it did. So it's an interesting dynamic that we keep kind of surprising ourselves. So is there a theoretic limit? Well, let's talk about what we're talking about limiting. Everybody knows what a deep neural network is. Very deep number of neural networks with hidden layers and all kinds of interesting techniques. And basically, what can we say about a deep neural network? It's a universal function, approximators, and it can model any continuous function to a degree of accuracy. Well, it sounds like got some wiggle room there, so let's get in there. Given enough neurons and appropriate training. Well, there's a limitation. We have to pay attention to it. Continuous functions, i.e. functions without discrete jumps. And continuous functions model a lot of the world, but not the whole world. Think about a sine wave. To a degree of accuracy, approximation close to the true function. So at the end of the day, we can get close, but maybe we don't get the exact answer. So we always have to live with some degree of error. And deep neural networks have taken us pretty far. They are the basis, for instance, for large language models. So we know through the research that we can scale these up and that they work in polynomial time, meaning that given a certain amount of time, you get a certain level of accuracy in your answer. There are lots of NP-hard problems out there. We're not talking about those. Problems are solvable in polynomial time. They're usually tractable, but that doesn't mean they're always practical. There's a difference between practical, and practical. Yeah, if I spend $1 million running this model and get an answer, but the answer only saves me $10, so why would I do that, right? So you have to relate the value to the resources you put into it to say whether it's a good idea to pursue that line of reasoning. Then you've got multimodal models. And the interesting thing about multimodal, which, by the way, is just you've got more than just text. You've got images and maybe voice, maybe even sensors, physical data. There's all kinds of things now being encompassed in the multimodal aspect. They tend to generalize better. Sort of makes sense, you know. We think of generalization from our perspective. We're very multimodal, right? We're very multimodal. So the more we make available to these foundational models a lot of different inputs in these different domains, the more likely they are to see the connections. To the point that was made about taking a 3D model and spinning it around from every different direction to recognize it, right? That's an example of multimodality. They also tend to demonstrate a better enhanced context management. Context being what you're holding, your short-term memory. You know, what's going on right now? What are all the little moving parts of the problem you're trying to solve? So, is there an end in sight? According to Matthew, the current research appears to say no. There's no end in sight. So, what does that mean? Well, we have to realize that we've been on a journey, and I wanted to take you through some of that journey. First, understanding context. We had a real problem with that in early LLMs, and we overcame it with the attention mechanism that's been developed. So that was a mathematical technique to keep the LLM focused on what you're currently interested in. There's actually a way they do that that's very cool. So we've largely addressed the attention problem. The next is inability to reason. Most LLMs couldn't. We've overcome that with COT. Yes?
So again, I'm an AI marketer, so I just want to, I'm just sorry, just add, because the topic was AI marketing. I don't think we've fully overcome the understanding context issue, to be honest.
Well,
because let me just add, because in the equation, it's all about the prompt. So if you're not doing a good, as a human, entering the prompt of what you want the large language model to generate, you're really not going to get a good result.
Agree with you more.
So I just want to say it's not just a technology issue, it's about how you work with the technology that gives you
I agree with
context.
you. In fact, but I would phrase that in the following contextual, pun intended, context. That when you talked about prompt engineering, you're applying the raw capabilities of your foundational models to a particular business problem. And what we do in prompt engineering is we eliminate the need for the user to have to provide the whole prompt and all of the context. We create a certain amount of context so the user can ask a question and not have to give all that context. A great example, you can use ChatGPT to go and create your little personal GPTs. You can say, well, this GPT is an expert on, and you can give it certain documents in certain areas that it should always focus on. Like if you're a programmer and you're only working in Python, then you could have a ChatGPT, personalized on Python. So you go in and ask a programming question, it doesn't give you an example in JavaScript, right? That's context, that's prompt engineering. So the more and more you're able to do to give a context, a substantial amount of context to the LLM, the better off you are. But the understanding context with attention mechanism is different. What we're talking about there is not the prompt context. We're talking about the LLM being able to take the context, find the thread of focus in it, and stay true to that. That's a different problem, and it's one that was...
Right, and all I was trying to point out is it's the both and that are needed
Yes, it is.
to be
You're absolutely
successful
right.
to solve the context problem.
I completely agree. And then, of course, with COT, to your point, it can actually show you how it got to the answer, it can show you all the steps, and you can tell it, well, you screwed up. Step 3, you shouldn't have done that, and it'll go back and adjust its reasoning. So we can even give it even more context. We can say, okay, show me all your steps. No, I want you to do something different in step 3. Which is very cool. I don't know if you played with the preview of, but it tells you all the things it's trying, the way it came up with the answer it came up with. It's very enlightening. So the next one is context length, okay? We had very limited context early on. We're now looking at million token contexts. Context is basically how much short-term memory is being applied to the conversation you're having, right? So the bigger that is. The problem is you could make an arbitrarily large context, but it would not be able to make use of it. So the advancement is not being able to just increase the context window, but having the foundational model make appropriate use of that larger available context without starting to hallucinate, without starting to lose the thread. Attention was one of the things, the attention algorithms were one of the things that made that possible. Compute resources, not as bad as they used to be. NVIDIA, I don't know if you guys heard this, they just launched their own model. They took Llama and tuned it up, and now they're actually getting into the game as a major provider. So, and of course the example of Elon Musk doing 100,000 GPU clusters. Okay, the hardware is out there if you want to pay for it. Training data, we solved that largely with synthetic data. And then finally, energy. I tongue-in-cheek say, well, we can just train when the sun is shining, but well, we can use nuclear. Like Microsoft just bought 3 Mile Island, and they're going to re-provision that and focus it on providing the energy for their big data center.
Finally, we'll accept
Okay. Okay. What's missing and what's next? All right. So can we just keep scaling up? Hang on, not so fast there, cowboy. The power laws do mean diminishing returns, like difference between practical and tractable. We can't yet, we're not seeing models that are dynamically adaptive or do a lot of self-improvement. Maybe that's the definition of the next thing we're about to dive into, right? So some new direction in tools, small language models, you see a lot of this now. Run Llama on your local machine and train it with your own documents. Okay, a lot of that going on. That could be a really fruitful area for lots of different types of functionality. Multimodal appears to help generalization, and generalization, of course, takes us closer to avoiding, the problems where it doesn't know what I want. And then finally, embodiment, real world physics understanding. I mean, we're also seeing a huge increase in the capabilities and scope of robotics. Well, if you put enough sensors on a robot, visual, touch, smell, physical interaction, and you tie that back to an LLM, you're getting pretty close to being able to generalize the same way humans do. And finally, algorithm improvements. There's lots of work, lots of really smart people doing lots of interesting work in algorithm space. So one way we can do this is maybe just create an AI that's a mid-level AI researcher capable, and then clone them and have an army of them. So instead of an army of people, we got an army of conversational agents that are doing all this research for us. If we could do that, and they were reasonably competent, we could see an exponential explosion in capabilities in a short period of time, because they are so much faster than humans at doing so many different things. And they can also collaborate very effectively. We're seeing lots of work in conversational agents that lead us to believe that, there is power in numbers and their ability to communicate. It's scary thought? Yeah, maybe.
Well, they each have their own context, so they can remember stuff and talk to each other.
Well, yeah, but you can also imagine they got a group mind. They can share a context. So there's lots of, when you look at conversational agents and you look at game theory and the way it maps into that, there's just some really amazing opportunities that were ideas that were played with back in the 90s when I first got into AI, machine learning and whatnot, but we didn't have the computational power, or some of the, certainly neural nets were nowhere near what they are now. So at the end of the day, sometimes these ideas catch up with the reality of implementation. And I think we're getting close to that. Okay. So real world evidence, follow the money. So Microsoft and OpenAI put $100 billion into what they're doing. We're seeing OpenAI is transitioning to a for-profit company, and they have, I think, $150 billion valuation right now. That's something that was in Matthew's paper. And Sam Altman said, hey, we're going to have artificial superintelligence in just a few years. That's echoed by a lot of researchers. Many believe we'll have AGI by 2030. So, I mean, you've got a little bit of a range there about what people think possible, but nobody's saying that actually do this for a living that it won't happen. The general consensus is, yeah, it's going to happen, and it's probably not going to take all that long. Okay, summary. We set out to answer the question, have we peaked on the AI yet? And the answer is no, a resounding no. It appears we're just getting started, and we need to start prepping now. And with that, I would just point you to Matthew's site. He's got some other articles, like the one Prepping for the Coming AI Revolution is very interesting. Got some general courses. I would urge everybody to take a look at that. So, questions? Thomas, comment, question?
I have 3 comments and a question. Firstly, talking about the use of synthetic data in training algorithms. I think you're crazy. I think that's enormously dangerous. One of the best things we can do with training models is identifying noise. And it becomes very difficult to identify what's noise and what's not noise. And the unknown unknowns that become problems are very difficult to identify by humans, such as hands. We can envision a situation where we are training an AI on how to draw images, and then you proceed to train it on images with the horrifying AI-generated hands, not realizing that was a constraint, and it got out of control and polluted your model, or you wasted a bunch of R&D on that.
Let me take one at a time, because
this is there's much more here, so real quick. I thought the use of 3D model is a perfect example of synthetic data in that anytime you have constraint functions like a physical object, there's no danger of polluting your synthetic data. Also, just an aside, you mentioned sine waves as
well, with max functions like a cap function, which gives you an abrupt transition, like max and min, things like that, and continuous functions can really. That's where symbolic regression.
Sine itself is
sine is continuous, but
continuous. It's actually all reals is the domain is codomain as well, which makes it really nice. The other thing I wanted to mention was if we're spinning up like hives of agents, there's a real danger of them communicating in a way we can't parse, and then even hiding that communication inside of communication we can parse in a way we can't parse. We've seen that with models speaking to each other, that they can develop their own languages.
Oh, when you get Alexis and Siri talking to each other.
Yeah. And they could even, like, every third character, for example, include a character that, like, they can encode in ways we can't predict, which there's a real danger of turning Skynet on in that case. Yeah. And then finally, I think just for the video, a question that I've had for a while, can you speak more to how LLMs can be installed and run locally? Because I've only interacted with them through the web client, so I have no knowledge around how that's meant to be done.
There's we have a couple of presenters who have spoken to that, like Matthew Denman was talking a lot. Yeah, and he's had 2 presentations here, both, and he was talking about how he was using stuff locally, and he's now got a business up and running where he's hosting a lot of the models in his own little rack at home, probably going to a colo at some point. But at the end of the day, there's an enormous amount of YouTube content out there on how to do that. But maybe somebody actually has an interest in that and has done it. I'd love to have them come and say, here's how I hosted my own LLM. I know, Josh, you did a little bit, didn't you?
Yeah, so Matt, actually, I went to one of his sessions before I played with ChatGPT, and then like the next weekend I tried to install a GPT Neo X node at home. And so there have been a lot of plays at it. Like the open source world has warmly embraced the self-hosted. So if you want like low-level compute stuff, one of the things I haven't done yet but have been itching to is to go to Hugging Face and play with some of those models and really dive in more on it. There was one called GPT for All that was around, I think, 2 gig to install, and it was like a slow, retarded version of ChatGPT. So if you say what's ice cream, it would say like a dessert made out of milk and ice cream and stuff. And so if you're looking at it from the perspective of natural language processing, which itself is just fascinating, if you're thinking about the compute level of usability on like a personal device, rendering 4 hours of HD video is going to be a hard no. But being able to do like an AI chatbot for your business or local reasoning or some basic image generation, it's just a lot of fun. And synthetic data is the only solution.
There's a link in Matthew's article to a mini GPT. I think that's the one you're talking about. And it's a new one. He says it's pretty good. I haven't played with it myself yet.
Well, and another, if you want to look at the programmer session, Vegas programmer session from last month, Josh Copeland did a demo of a self-hosted model to use as Copilot. So like instead of using Microsoft stuff, you can do everything all on your own. And I guess I'll just, since I have the mic real quick, we've gone all the way to Apple has now taken that real lead on local hosted models on their devices. So in terms of looking at like generative AI on our device where it's not touching the cloud, my God, we already have the compute power. Like, this is nuts.
It is. It's cool. Great. Were there any other questions? Comments? Yes, we got one more over here. The mic.
So most of the talk and most of the hype I hear is about LLMs. I was just wondering if you could touch on kind of the latest in other approaches. So LLMs are good for if you have a conversation and you're talking about probabilities of the next word. I don't hear a lot about like how you represent knowledge, how you represent understanding, how you represent like an actual thought process.
You know, that's a great question. And again, I'll point you to Matthew Denman's last presentation and the one prior to that, because what he did is he talked about semantic dictionaries, where he would suck in large amounts of data from documents that were important to him, like his whole email history, and he would then codify that in such a way he could use search quickly, and then he would use the LLM on top of that, so he'd tokenize a lot of it. So he was taking semantic knowledge and combining it with a local LLM to do exactly that. There's been a long history of attempts to take large documents and create a searchable database and then draw semantic understanding out of that. Semantic networks, for instance. Combining that with LLMs is pretty cool. What you do is you take your semantic network, you tokenize it, so now you have a common language between the two, right? Because tokens are what LLMs run on, and you can put that together and create contexts that are semantically heavy. And so there's a lot of interesting work going on there. If I find a paper on that, maybe we could pull that into scope for everybody to look at. So I thought go ask Mr. Rinzi if he has a good paper or knows of one on that. Go ahead.
I just want to make one comment to the gentleman over there that said synthetic data is dangerous. I think we can't generalize synthetic data. There are different types of synthetic data, and some are more useful while others may not be.
Well, yeah, and frankly, I'll give you an example where synthetic data is commonly used. In symbolic regression, what we're doing is trying to find polynomial expressions that allow us to predict some behavior based on data. We generate all sorts of data with a mathematical formula, right? And with a certain amount of randomness, and then we go back and see if we can get the machine to come up with that formula on its own, and how long it takes to do that. And so we've been able to do that with very high accuracies, just very, very long training time. And these are simple polynomial formulas. They might be nested, so many layers of them, but unlike a neural net, where you can't tell what's going on, you can actually see, it's just a polynomial, you need algebra level understanding, you can see what the output looks like. So there, synthetic data is absolutely reasonable because you're using a formula to generate the data, and then you're training on the data to get the formula. When we talk the model example that was given, where you're spinning it around so you can see it from all perspectives, because that was super. That's a great example. Other synthetic data might be a little less trustworthy. Like if you have a bunch of literature and you're generating more literature on that, what are you really doing? Because you could, the hallucination that LLMs can inject to that could lead to some pretty bizarre results. So I guess, yeah, buyer beware, practitioner be careful.
Not all synthetic data is good data.
No, and the other thing too about data in general, you've got model bias, right? You got selection bias, you got all the different biases that you have to understand, and data bias is a big one. So you can often overfit to a data set. You always have to train on one thing and look at something, have it try to apply the model to data it's never seen. So that out-of-sample testing is very important. There's a whole conversation on that, right? But yes.
Just a specific question, kind of off topic of the synthetic data. In your bullet point, talking about the context being able to go beyond 1 million tokens, is that just in reference to Mamba, or is that something else?
Well, there's a few models that are trying to get there. I followed the link in Matthew's paper to see which ones in particular he was looking at. It was broken. I was going to ask him about that. But yeah, there's the Llama and some other models that are starting to get way up there. I think too, you got to realize, us common folks don't get access to all the latest cool stuff. I mean, yeah. There's a lot of stuff out there that we haven't seen yet that's actually being used by researchers in the field. who have the budget and resources to exercise these things. So.
And I
we're
think Google
washed.
and Meta both just said they were going to go with some nuclear investment as well, in addition to that Microsoft one.
Nuclear is a good answer. I certainly don't want them to burn more coal to get this done, right? I don't think any of us want that. There's a lot of renewables out there to use. Like just do it while the sun's shining. The argument against that is, yeah, that means your GPUs aren't doing anything for a portion of the day. But you can throw batteries at it too. It's just there are lots of cost-effective, reasonably climate-friendly ways to get this done.
And we like the DOE in Vegas.
Yeah. Thomas?
I just wanted to circle back around. I know we're hammering on this to the synthetic data point, but Josh is a bit of a leader in the space, so I wanted to hear his opinion on this, right? Which is that, well, I think we can all agree that synthetic data is extremely efficient when there are underlying mathematical truths that ensure correctness. But anytime you're getting off into more predictive elements, there's real danger of error compounding, right? So for Josh and others, my question would be, do we think we've reached the limitation of real world data gathering? I think we're running into a space in the future where things like neural laces might become commonplace, where we could maybe utilize some of our scanning technology to ingest much more higher resolution data in our common spaces. And my question would be, do we really think we've reached the limit of our data resolution ingestion? And isn't that going to be the thing we're going to be looking to do in the next 20 years?
Everybody in here can add their own personal. Have you reached your level of data acquisition limit? I mean, everything that a person can take in, we're all limited by that. And we do a pretty good job in general, at least most of the people in this room do, I hope, in applying what we've learned to conducting our lives. The opportunity for foundational models going on way beyond, LLMs and multimodal, and this is my opinion, Matthew hasn't expressed this, but at the end of the day, they have the potential to ingest a whole lot more life experience than any one individual person can. I mean, we're not there yet. We may not be there for a number of years, but they can go beyond us in terms of their ability to ingest the world, experience the world in a meaningful way that they can use to make decisions. It's scary. I mean, it's very much possible, though.
The whole what an embodied idea.
Yeah, embodiment, and not just that, but I mean, we're all going to be cyborgs. Probably one of my favorite things is smartphones. We're all cyborgs now. We really are, right? It's just not built into us. So I guess we'll call it a close. I would suggest anybody that's not a member of the AI Meetup group, go to meetup.com and join. I send out, a few days in advance whatever the next, topic's going to be, so you can decide whether you want to make it out. And I appreciate you guys coming. Thank you. The two coolest participants right here. I love the dogs.